Hi there, in this video I'm going to do a past exam question on logarithms. So let's take a look at this problem. So here's the question. Question number 3. Find, given your answer to 3 significant figures where appropriate, the value of x for which, and in part A, 3 to the power of x is equal to 5. So let's think about how this can be solved. Let's go back to the paper and pen. So here's the equation, 3 to the power of x is equal to 5. Now it's impossible for us to make 5 a base of 3 to the power of something. If it was possible, then we can use the fact that if the base terms were the same, then the powers are equal. But in this particular case, I can't make 5 a base of 3. So we need to take logarithms or natural logarithms on both sides. So let's take logarithms on both sides. So by taking logarithms on both sides. So by that I mean writing log. Log means log to the base of 10. So log is the shorthand for log to the base of 10 in front of 3 to the power of x. And I also write down log or log to the base of 10 in front of the right hand term 5. So that is the first step. Now the second step is wherever you have a power, apply the power rule. So I have a power of x. Let's use the power rule. So the power rule says whenever you got a power, bring it to the front. So in step number 2, let me bring that power to the front to give me x log of 3, and that is equal to log of 5. So let me go back, let me reiterate that I've used the power rule here. Whenever you have a power, bring it to the front. So that's going to take us to the last step, step number 3, because we need to calculate x. So if I rearrange, x then will be log of 5 divided by log of 3. So here's where the calculator comes in. If you calculate log of 5 divided by log of 3, you should get an answer to 3 significant figures of 1.46. So it's 1.46 to 3 significant figures. So that should be the solution to part A. Now, before I move on to part B, if you're unaware of this method, I have created a video explaining the method step by step, and I'll provide a link to that video in the description below. However, let's continue. So back to the screenshot, part B. So in part B, we have log of 2x plus 1 to the base of 2 minus log of x to the base of 2, and that is equal to 2. So we need to solve this equation also to find the value of x, and wherever appropriate we'll round to 3 significant figures. So let's see how this is done. Let's go back to the paper and pen. So over here, what I'm going to do is I'm going to use the law of logarithms, or one of the law of logarithms, specifically to simplify this left hand term. So I'm looking at the left hand term, and remember this law of logarithms. So let me jot down the law. So if you have log of a to the base of c minus log of b to the base of c, that is the same as log of a over b to the base of c. So my eye's on this term on the left, and as a result of this law we can rewrite this equation. So it's going to help us over here. So let me rewrite the left hand side using this law to give me log of 2x plus 1 divided by x, so divided by x to the base of 2, and that in turn is equal to 2. Now from here on, there is another rule that we can use. We can use the fact that, so let me take this red pen. If b is equal to a to the power c, I could write that as c which is log of b to the base of a. So this is a relationship that switches an equation which is in index form. So this part of the relation is in index form. And we can switch an equation from index form to logarithmic form. So you can use this relation to go from index form to logarithmic form, or from logarithmic form back into index form. Now, over here we have our equation in logarithmic form. Let's use this relation to go back into index form. So if you make the comparison here, so let's make a comparison. So let me take a different colour. Now the base is 2, so a is 2, a is the base, a is 2. Let's make a note, a is equal to 2. And in this case also we have b. b by comparison is this term. b is 2x plus 1 divided by x. So let's make a note that b, that is 2x plus 1 divided by x. So all of this is b. And how about c? c by comparison is 2. So c, 2. So if I rewrite this equation over here, so in this case b is 2x plus 1 over x. That is equal to a is 2 to the power of c, which is 2. So that is what I have over here. And 2 to the power of 2, that is 4. Now if I cross multiply, so let's cross multiply, 2x plus 1 times 1 is 2x plus 1. And that is equal to x times 4, so x times 4 is 4x. Now if I rearrange, if I take the 2x to the right hand side, I'll have 1, which is 4x, minus 2x, which is 2x, which means that x, when I rearrange, is half. So that is what you should have for x. So that is the solution to part B, and that also ends this question. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related questions, and I hope to see you again. Thank you.